Hello everyone. In this video we're going to be taking a look at changes and improvements that I've made to the font asset creator. We're also going to be taking a look at the font fallback system in TextMesh Pro, which although is not a new feature, it is still something that many users are not familiar with. We're also going to be looking at font assets and some of the changes there and see how these affect the font fallback system. Let's take a look. Now, everything I'm about to show will be available in the next release of the TextMesh Pro package, which will be available via the package manager and for Unity 2018.3. First up is the font asset creator. To access it, we go to Window, TextMesh Pro, Font Asset Creator. I've already done so, so I'll bring this window into view. Now, at first glance, it hasn't changed all that much from a visual standpoint, other than it has undergone some skinning as compared to previous versions of TextMesh Pro, but the options are the same. So source font file is the font file you want to use to create your font asset from. Sampling point size to padding, nothing has changed there, other than it's important to remind users that the ratio of sampling point size to padding determines the effective range of the material properties. In other words, it controls how thick that outline can be and how far that shadow can extend. Now, typically you want to aim for a ratio of about 10%. That gives you something versatile to work with. It's also important to keep in mind that when you're using the fallback system and you're going from a primary, which would be the font asset assigned to the text object, to a fallback, you want to make sure that the ratio of sampling point size to padding matches between the primary and the fallback. That way you can get a consistent visual appearance in terms of the thickness of the outline and how far the shadow extends. So if your primary was using a sampling of 90 and a padding of 9, and the fallback was using 50 and 5, then it would work and appear visually consistent on screen. Packing mode, Atlas resolution and character set, no changes there. However, we do have new render modes. So right now I'm going to be using this Sdf 8, but with the current font asset creator, you have distance fields 16 and 32. Those will continue to be available. Sdf 8 is just this mode that I'm going to use to show, but it's comparable to Sdf 8. But the new modes are Sdf Aaa and Sdf Aaa hinted. So we'll start with Sdf 8. So when I click Generate Font Atlas, you saw a bunch of stuff flash, and that's just feedback now on packing, and it says, hey, I packed whatever number of glyphs in 190 something milliseconds. But now as we can see, it's baking the SDF, which can be a lengthy process, somewhat painful to wait for, because it can go from 5 minutes to 30 minutes to more than an hour if you have tons of glyphs, which isn't really cool. So I'm going to stop this and we'll take a look at a new Sdf Aaa mode. So I'll clear this and we're going to generate our font asset. So now, as you can see, it is substantially faster. So in this case, we generated 251 glyphs, so we packed them in 195 milliseconds, and we baked the SDF in 219, which is way faster. So hopefully that's going to make the process of creating and updating font assets a lot more enjoyable, although I'm not sure that's something that's enjoyable, but at least less painful and time consuming. Now, I've also updated the feedback window where now it says, hey, the font's Arial, its style is regular as opposed to bold or italic or condense or heavy or black and so on and so forth. The sampling point size is 82 and our ratio is 11. Characters included, we wanted 306, which is what extended ASCII is, and it basically included 251 because 55 were missing from the font file, and here we have a list of those that are missing, and you can rely on the font asset creator to accurately tell you what is missing from a font file. Next, just so we can see the next part, I'll pick a sampling point size that I know we can't fit everything in. And now it says, hey, we wanted 306, we got 214, 55 are missing from the font file, and 37 were excluded. So if I scroll down, those 37 were excluded because we simply could not fit them in the given atlas space. So those are the changes to the font asset creator, and the key one is it's substantially faster now to create and update your font assets. So now let's go take a look at the font fallback system. The font fallback system was created to allow us to overcome the reality or the fact that we can only fit a finite number of glyphs or characters in a given texture space. Now, this is really important because on many mobile devices, we are limited to a maximum size of 2K by 2K in terms of textures. And so if you're dealing with Chinese, Japanese, and Korean, whose character sets are pretty large, you can't fit all the glyphs in a single font atlas. So the font fallback system was created to allow us to overcome this and allow us to distribute our glyphs across multiple font assets. So to help us demonstrate the font fallback system, I'm going to create a new TextMesh Pro object. I could go to UI and bring up a UI with a canvas text object, but I'm going to use the normal TextMesh Pro object, which is under 3D Object, TextMesh Pro. I'll extend the rect transform and just type some text. So right now I'm using Liberation Saint, which contains the extended ASCII. So what if I want to display like a Greek character, like the character omega? So in order to access a UTF-16 character, because the Greek character omega is in the UTF-16 range, I would type /u with 2 hexadecimal pairs. So in this case, it's 03A9, and that would basically display the Greek letter omega. Now, in our case, it's not in our font assets, so we see the missing glyph symbol. Now, as a user, you have control over what glyph is shown when TextMesh Pro can't find the given character. So if you go into TMP settings and you look at missing glyph, right now it's using a value of 0, which is the square. But if I was to put 65, which is the letter A, it would display the letter A, or 32 would be a space. So you can eventually assign whatever you want. So, but by default, it's the square. So back to our text object. So now in our case, we want to have this Greek character show up. So what we're going to do is we're going to select our Liberation Saint font. We're going to go to it. And for each font asset, we can assign a list of fallback font assets. So in this case, we're going to add a new item in our list. And we're going to look for Liberation Saint Greek. And as soon as I assign it, you can see that now our missing glyph was replaced by the character omega. Now it's important to understand that the fallback list, when TextMesh Pro looks for a character, it will look at the primary font asset, which is the one assigned to the text object. Then it will look at the fallback list, and it will look at the first fallback. And since fallbacks can have a list of their own of other fallbacks, it will recursively go through the first fallback and any fallbacks that are in there. And if it doesn't find the glyph that it's looking for, then it will go to the second item on the fallback list. Now, what if we want to display, for example, Apple's logo, which is from the Font Awesome symbol and icon library. So I'm going to go /u for a lowercase, again, UTF-16, F179, and that's the glyph for Apple's logo. So like we did previously, I can go to my font asset. I can add a second item to my fallback list. And in this case, I'm looking for Font Awesome. And as I assign it, we can see this Apple logo show up. Now, unlike the previous example where we're using Liberation Saint as the primary, it definitely makes sense to fall back to Liberation Saint Greek or Cyrillic and so on and so forth when we're using the font Liberation Saint. But what if in our project we're using multiple fonts and we wanted to use Font Awesome for all of them? Well, I guess it could make sense to assign Font Awesome to every single font asset as a fallback, but in this case, we're trying to use it as a general fallback. And in that case, instead of assigning it per font asset, I'm going to remove it, which now will have the missing glyph. In the TMP settings, if I can type it correctly, in the TMP settings, we can have a general list of fallbacks. So here I'm going to assign Font Awesome because now I want to make sure any font can actually access Font Awesome. So the fallback system allows you to specify specific fallbacks per font asset as well as general fallbacks. Now, it gets a little bit not more complicated, but more flexible too, because we can also use sprite assets in this. And just to catch up everybody on that, obviously we can access graphics and sprites in line with the text by typing sprite equals 0 and whatever stuff. And whenever I do this, I'm accessing a sprite by index. I could also access a sprite by name, but in this case, if we go to our emoji1 asset and I expand it, we can see that this emoji is index 0, which is why it showed up, but we can also give it a name or a Unicode value. In this case, the sprite asset has been given a UTF-32 Unicode value. So going back to our text, if I delete this sprite tag, and now I access the UTF-32, which is slash uppercase U with 4 hexadecimal pairs, so 0001F60A. Now I can also access a sprite from a sprite asset in the text by referencing its Unicode value. And the reason I'm showing this, although this is not coming from a font asset, it is part of the fallback chain. So TextMesh Pro, when you're asking for a glyph, it will look at the primary font asset to see if that glyph is available. If it's not, it goes to the list of fallbacks that I described before, and it will go through all the different fallbacks there. If it doesn't find the glyph, then it will look at the text object, because the text object can have a sprite asset assigned to it. In this case, it would look for any sprites that have been assigned a Unicode value that we're looking for. Now, if it doesn't find it, then it goes to the general fallback in the TMP settings, and then they would go through that entire list. And if it doesn't find it, like in this case, it will look at the default sprite asset, looking for any sprite that may have a Unicode value that matches what we're looking for. And then if it doesn't find that, it will go to the default font asset and all of its fallback. And then if it still can't find it, that's when it displays the missing glyph symbol. As you've seen, the font fallback is pretty extensive, and although in theory you could create a list of fallbacks and use a bunch of fonts assets that only contain a single glyph, that would be technically abusing the system. And although it would work, I don't advise doing so. Now, it's also important to understand that the fallback system can track any circular references, so by default it will only search a font asset once for any potential glyphs. Now, before we move on to discussing the changes to the font asset, there's one more thing that sort of involves the fallback system. So what I'm going to do is type sprite space name equal and reference a sprite by name specifically, and in this case we see this heart show up. Well, again, we're using emoji1, so if we look through the sprites in emoji1, we don't see a heart, and there's no heart here. Well, guess what? Sprite assets also have the ability or their fallbacks of their own. So you can also assign fallback sprite assets to a sprite asset. So in this case, it finds the heart through the fallback. So that's it for the font fallback system. As you've seen, it allows you to overcome the limitations in terms of how many glyphs we can ultimately put in an atlas, and allows you to distribute them throughout multiple font assets, or in the case of sprites, multiple sprite assets. So next up, we're going to take a look at the changes to font assets. Font assets are the main resource used by all text objects. And thus far, to create or update font assets, we've been using the font asset creator. Now, as we saw earlier in this video, this process has been significantly improved and sped up by the addition of the new Sdf Aaa and Sdf Aaa Inted render modes. And although one of the goals in making these changes was to improve the workflow and make it much less time consuming to manage these resources, that was not actually the primary motivation behind this. So without further ado, let's take a look at what the real reason. So let's create a new font asset, but instead of using the font asset creator, let's get it out of the way. Let's go to our text object and erase all the text. And we're going to go to our fonts right here, and I'm going to select Arial. And although I could right click and go through the menu, they're going to be off screen. So I'm going to select the font asset and go through the top menu, which is Asset, Create, TextMesh Pro, and Font Asset. So now we just created a new Arial SDF font asset. We're going to go assign it to our text object right here. I'm going to expand this font asset just so we can take a look at its atlas. So I'll select that and actually bring another inspector into view and lock the inspector on it so we can observe what's going on. So I'm going to go back to the text object and start typing. So as you can see here, we are now dynamically adding glyphs into an atlas using TextMesh Pro. And this marks the introduction of the Dynamic SDF system for TMP, which happens to be the #1 feature that's been requested since the initial release of TextMesh Pro. So let's dive into this and take a closer look at our font asset. We can see our face info settings. We have our generation settings, which are new. So we can see the source font file is Arial. Our atlas population mode can be dynamic or static. If it is set to static, it basically means that whether or not we have space in the atlas, we're not going to try to add anything because it is static. If it is dynamic, and provided we have room in the atlas and that the glyph we're requesting exists in the font file, then it will be added into the atlas automatically. We have our atlas render mode, sampling point size, padding, atlas width, and atlas height. We'll come back to play with these settings after I go through the whole font asset. We now have the full font weight table, which means instead of having just regular plus italic and bold plus italic bold, we now have all font weights exposed. Now, all of these can be a mixture of static and dynamic. And the fallback system, same thing. So the dynamic support works throughout the entire fallback system. Contrary to before, we now have a character table and a glyph table. So the reason we have the two is each character basically has a Unicode value and they reference a glyph. The glyph is the visual representation of a character, and glyphs are what we store in the atlas. The reason why these two are broken up is because it's possible to have multiple characters using different Unicode values and yet all pointing to the same glyph. So that's one of the reasons that's there. And then, so we have our glyph table, and then we have our kerning table or glyph adjustment table. So now let's play with our generation settings just for fun. So let's assume this font asset we're not going to change. And as such, we have like a lot of empty space in our texture. So let's just for fun go change our generation settings to put them and set them to 512 by 512. And let's change, for example, our sampling point size to 128 and padding of 14. As soon as I hit apply, it automatically updates and we can see the changes reflected right there. So let's go back and reset it back to 90. Padding of 9, 512 by 512. I hit again, and we can see that it was updated automatically. Now, let's, for fun, change this and mark this font asset to static, which means we're not going to be able to add anything else into it. And we're going to go create a new fallback from this font asset. So I'm going to select Arial. I'm using a keyboard shortcut to create a new font asset. We're going to take a look at its atlas because we want to see it adding glyphs into it. And I'm going to go assign this newly created dynamic font asset as a fallback to our initial Arial font asset. So I'm going to drag it here. And now I'm going to go type over here. So we're going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're going to go /U03A9, which is the Greek letter omega. So as you can see, it was added into the font atlas itself. So again, it looked at the primary, it's static, it doesn't have the glyphs, therefore it looked at its fallback, and it does happen to a fallback that's dynamic, and as such it added the glyphs in there. Now, a quick thing to demonstrate that's kind of interesting, if I go to this other asset and I hit reset, whoops, wrong key, I didn't mean to lock, and I go reset. Now the reset is off screen, my apologies for that, but nothing seems to happen when I hit reset. Well, actually there's a lot that's happening when I hit reset. So if I go back to the font asset and I remove these additional glyphs that are here that are actually coming from the fallback, and I go back to the fallback and I hit reset, you're going to see these disappear from the atlas. So when I was doing it before, because the text object was requesting those glyphs, it was actually resetting the atlas. Then the callback was going back to the text object, which was then saying, hey, I need these characters, and then they were getting added automatically all inside of the same frame. So in terms of the system, it also works, like I said, through the entire fallback and general fallback. So for example, if I go back here and I type /u F179, which is Apple's logo, we can see that it's not available. The digits were added to the first fallback, including the missing glyph symbol. But in this case, what we wanted to do is we're trying to add something in the general fallback. So here I have Font Awesome. So let's take a look at it, and we'll unlock this atlas and take a look inside. We can see it's completely empty. We take a look at Font Awesome, and it is set to static. So as soon as I switch it to dynamic, we can see that now that told the text object, hey, one of our assets changed. It updated the text object, it requested the apple. Now it's able to add it because it's dynamic, and it added it to the atlas. So if I go back here and I type another character from Font Awesome, F185, then we get another character from it. So how should this new system be used? Well, just like today, you should prepare ahead of time your font assets and make sure that these include all the known text currently in the project for any given language or groups of languages, and that these assets are marked as static. This way you're going to get the best performance possible from any of these assets. And then rely on the dynamic system to catch whatever other glyphs may be coming from user input or any other source where you could not predict ahead of time that these characters were going to be needed. So basically you're going to have a bunch of pre-prepared font assets that are static, grouped with several potentially font assets that will be set to dynamic to catch the balance of the stuff. Now, in terms of the performance of the dynamic system, if we're looking at something like a Galaxy Tab 4 device, which is probably like 2015-ish in terms of when these were released, we're looking at about 3.6 milliseconds per glyph in terms of individual glyphs. Then if we're rasterizing more than one at a time, there's an economy of scale, but that's sort of what we're looking at, and obviously much, much faster on desktop. But the point being that 3.5 milliseconds is substantially faster than any human can type any text. So from a usage point of view, provided you bake everything ahead of time that is known in the project and only rely on the dynamic system for user input, the experience from the user's point of view should be very smooth, and they shouldn't notice anything whatsoever. But because of the dynamic system, it guarantees you that whatever glyph will be typed for any given language, provided they are in the font file, those will end up being displayed on screen. Now, there is more to the dynamic system. So, for example, I can select a font asset and go to let me make sure I select it, and go to Update Atlas. And if I bring this back on screen, or actually select the Arial 1, which would be more appropriate, you can easily take something that was filled in dynamically, bring it up in the font asset creator, make changes, additions, and so on and so forth. So the system is going to be very flexible. Now I'm still fine-tuning all of this. So basically doing a video like today enables me to further test it. I spent last week at Unite doing demos and testing the system. So in terms of when will this be available, as I said earlier, the core of the dynamic system is already in the latest beta. So now you're going to have to wait for the new TextMesh Pro package for 2018.3 to be released, and then you'll have access to all these new features. So that's basically it for the video. I'm sure you're going to have feedback and questions, so please feel free to post on the Unity forum in the Unity UI and TextMesh Pro section of the forum, and it will be my pleasure to answer and provide any additional insight on whatever aspects of the system you're most curious about. So thank you for watching, and we'll see you on the forum.